All right, everybody, we're about to start. Please take your seats. Keep your hands and feet inside of the vehicle all the times, please. We're gonna have Roman Khavronenko talking for us, sharing his knowledge. He's a senior software engineer at VictoriaMetrics. Perfect. There are some spots over there free if you want to sit down. I see one here that's with a jacket. I don't know if somebody left the jacket there. Perfect. Did you enjoy Mario talk before? Come on, don't be shy. Did you enjoy the talk? Perfect. I like that. Awesome. We are really glad to offer you a pretty varied talks throughout the day. It's pretty special for us to do this for you. We love open source, and it's also really nice for us to share our love to you. Okay, so Roman, he's going to present the talk, Monitoring in Open Source Project.
Yeah, hello everyone, and welcome to my talk. I know it sounds a bit silly, but you will get it in the end. And I know it could be hard to see the slides from the last row, so you can scan the QR code and you will get this presentation on your phone, so you can check the slides. So my name is Roman. I'm a software engineer. Oh, you need time, sorry. Yeah, take your time. Okay. Okay, cool. My name is Roman. I'm a software engineer. I have experience about 10 years or something like that. And the last couple of years, I'm working on an open source project called VictoriaMetrics, and it's dedicated to monitoring. Please follow me on Twitter and on GitHub. VictoriaMetrics is, as I said, open source project and also a monitoring solution. It's available on GitHub under Apache 2 license. It has pretty good community and big companies using it, so take a look if you have time. What this talk will be about? Well, mostly about maintaining open source projects, but it also touches monitoring of complex distributed systems, and people who are familiar with Prometheus or Grafana or VictoriaMetrics will find it the most interesting. Okay, how open source project should look like? Well, if you think of a good example of an open source project, you probably will think about something like Kubernetes or Prometheus. And if you will try to describe it to a friend, you will likely say that they have really rich, extensive documentation. They have many examples. They have transparent roadmap, guides, and a little bit of code, which actually makes the project to work. But what it usually looks like this. There is a developer. He has some code. It works on his machine. So he deploys it to GitHub. And probably there are some other people who can try to run this code. Maybe this code will even have one README file with 10 lines explaining how to launch it, and that's all. And if there will be a community or users of this project, they will start having questions. And they will ask how to use this project for my scenario, why my config doesn't work, why it is exiting so fast or whatever. And because the project is black box, those answers will be directed to the maintainer, to developer. If there is no documentation, then maintainer is documentation. And with time, when popularity of the project will grow, developer will feel overwhelmed because he will need to spend all his time to answer these questions, and everyone will get upset. Developer will be upset, he is overloaded, he can't write code, he needs to answer questions. People will get upset because they can't trust this project, they waiting too long, they don't get answers fast enough, and the project will be upset because it could be a really brilliant piece of code, can be perfect, but people can't trust it and they will not using it because it's black box. So what we need to do, we need to make it transparent. We need to reduce this number of questions and put user in the loop where user can not only generate those questions, but find answers to those questions. And in this loop, the community can help you with documentation, with examples, with sharing their stories, And then as a developer, as a maintainer, you can do what you like to do. So from my experience, to answer some complex questions from a user, we need two things. Well, basic understanding of the matter. Like, for example, monitoring. In monitoring, we have metrics. Metrics looks like this. Metrics are exposed by applications. We collect the metrics, and we provide API to query those metrics. That's a basic understanding of the system. And then we need context. Like, I'm using your monitoring solution. It is OK. But when I put like 1 million samples per second in it, it starts to return me errors. This is the context. If you have understanding and a context, you can generate an answer. So why this picture is here? Well, first, it is really nice. It has a good look. I really like it. And another reason, it has word monitor in the title. A shepherd and her dog monitor the sheep. So the sheep, we have a couple of sheep here, a herd, and it's usually called cattle, and DevOps people call their services and application cattle. So this is some kind of resource you care about. And as a DevOps, as shepherd, you look after that cattle. And you are using some tool, dog, or maybe watchdog, to look after that cattle. So it looks really good. It works really good. It's traditional, old-fashioned. But what will happen if you have not like 20 sheep? What if you have thousands? What if you have millions of sheep you need to look after? So probably you need more than one dog. Maybe you need hundreds of dogs. Maybe you need a distributed system of dogs, coordinated, so you can effectively monitor 1 million of sheep. And this leads me to the question, how complex could be the modern monitoring system be today? So here you see an architecture of open source project called Cortex. It is also time series database, and it looks pretty complex to me. It is a distributed system with many moving parts. All of them are interconnected. It's really hard to understand what is happening here. And if something goes wrong, you will likely spend a lot of time to understand what is happening. Thankfully, this is not a project I'm working on. I'm working on this project. It's much simpler, but still, it is a distributed system. And word distributed here stands behind complexity. If you heard distributed, then the system will be complex. So how can we reduce this complexity for maintainer and for community? How we can make it easier to understand? Well, really easy principles. We need to write good documentation. We need to instrument it with helpful logs, with metrics, maybe with Grafana dashboards to reflect the state of the system, and instrument it with alerting rules, so user get automatically notified if something is wrong. But it's easy to say than actually implement it. Let's see how we do it in VictoriaMetrics, and we start with Grafana dashboard. So VictoriaMetrics critical components have Grafana dashboards, and we store them in GitHub repo. We ship it with Helm chart, with operator. We reference links to these dashboards in our documentation, and we encourage users to use it, to use these dashboards. This is how Grafana dashboard from VictoriaMetrics cluster version looks like. It's a bunch of numbers and lines. And I can say that this dashboard shows the context of what is happening to the system. But it is meaningless until you know how this system works. So in order to provide this basic understanding of the system, we put some links here. Like you can go to the documentation and read more about this. But usually people don't do this. So we put also information icons to each panel here, explaining what it shows. Here's how it looks like. So for example, we have a panel called slow insert. If you are not familiar with VictoriaMetrics, you don't have idea what does it mean. But if you click on the help tooltip, you will get some explanation. You will get this basic understanding. And we're trying to be really helpful with these descriptions. So we say that the less value is better, for example. And user can, from the first glance, understand if it is good, if this graph is okay or not, based on the retrospective view. We also can say what is the safe threshold here. We can also give some links to the documentation so user can go and read to understand more. Okay, if you ever try to implement observability, to add metrics to your application, to your software, or to build Grafana dashboards, you probably asked what I need to do first. And if you Google this question, you will likely see how big companies do this. So big companies, for example, Weaveworks, suggest you to follow the RED principle, RED method. RED method implies that for your application, you need to look after 3 signals: rate, errors, and duration. For example, if you have some HTTP server, then served requests per second, the rate, errors are failed requests, and duration is the latency of requests. So you can add these metrics to your application. You can put those metrics on the Grafana dashboard. Google suggests you to do the same thing with 4 golden signals, but they also add saturation signal, which usually is about how my network is saturated, how much CPU I use, how much memory I use. You can also put this on the Grafana dashboard. It will be meaningful, it will be helpful, but it doesn't answer on the question why. Why my resources are saturated? Why I have so many errors? Why requests taking too much time? So in dashboards for VictoriaMetrics, I'm trying to explain, to create a user journey. So a user can use hints and suggestions to go to the root cause. For example, this is a real case from our sandbox. Something happens to ingestion rate, and based on this, user doesn't know yet how system works, but he can click on the tooltip and check that that for ingestion there is a separate component responsible for ingestion. It is called VMinsert. So maybe you want to check VMinsert metrics. Before reading this, user understanding was that there is just a VictoriaMetrics. It accepts writes, and that's all. That's what I know about the system. But after this, I now know that there is a VMinsert, and we will go and check VMinsert metrics. And in VMinsert metrics, we see another anomaly and another explanation what it could cause it. So for example, this, we see that, well, if you see this anomaly, then probably you need to check CPU usage of VMinsert. Maybe it is overloaded. If it is not overloaded, you need to go check VM storage metrics. So we go to VMinsert, we check its CPU usage, and it looks not overwhelmed. It looks even lower than before, so probably something else happened. We go to VM storage metrics, and we see anomaly of merge speed. It doesn't matter yet what merge speed actually means, but it will suggest you that CPU and I/O was saturated during extensive background mutation of files on disks with further recommendations. But yet here on this stage, you will have better understanding what's happening. Writes go to VMinsert. VMinsert can write to one of VM storages. Here's the bottleneck. So that's a journey which helps a person to understand, to look through the metrics, to look through the code and understand what is happening to the system, to see the root cause. Okay, so I spent probably those dashboards that I showed, I created them like 2 or 3 years ago. And since then, I discovered cool features that you can use in your Grafana dashboards. So one of them is these tooltips that I showed you before, and I recommend to use them and put really meaningful description here. So for example, we have some panel slow queries. You don't know what it means, but in the description, you will see the explanation what it is, which setting is responsible for it, what is default value, and how you need to understand this panel. Like the less value is better, for example. Another thing, resource saturation. So here are 2 important things. First, VictoriaMetrics cluster consists of these 3 components, and each component can be represented by arbitrary number of instances. You can have 20 storages, 50 VM selects, 10 VM inserts, etc. But here on the graph, we show only 3 lines. We select only those components which are the outliers, which are having the max saturation. And this graph will look similarly similarly to installations with small number of instances and installations with thousands of instances. And looking at this, you can instantly see that if there is an outlier and if you need to investigate more. And another thing, we do not show the absolute values, we show percentage values, because it's much easier to say if resource is saturated when you see the percentage usage instead of gigs of RAM. So if you identify the outlier, you can then use drill down option. In Grafana, you can define a special drill down option which will take user with filters to another page, to the custom panel. So if you want to see the real usage of memory, you can click on drill down and you will be taken to the panel with detailed overview where you can check if like maybe only one VM storage consumes too much memory and the rest are fine. And you can use this information for further troubleshooting. Another thing, non-default flags. So VictoriaMetrics components are configured mostly with command line flags. Command line flags usually have really good defaults, and these defaults are responsible for cache size, for max memory usage, for max query complexity, etc. And we usually do not recommend change them. But when user wants, they can change, they can set arbitrary values for that, and no one can stop them from doing this. And usually this is source of problems when user don't understand what he is changing. So here we can see what was overridden by a user. And how we do this, each command line flag in VictoriaMetrics is exposed via metric called flag, and it has a label isSet. So isSet will be equal to true if user has overridden it. And we can instantly see what is the custom configuration of this installation. Another thing, annotations. So usually software starts to break when you update the version of it. And we have an annotation which will display exactly the time when VictoriaMetrics component, any VictoriaMetrics component was updated. And with this annotation, you will have this blue dotted line showing the moment of time when something changed. And if after the change you see service degradation, ingestion rate dropped, or memory usage increased, well, you can quickly deduct that it is caused by software update. So maybe the first thing you need to do is to roll back and then investigate. You don't need to spend hours of troubleshooting. You can see it instantly, thankfully to this annotation. Another annotation, process restarts. It's also track if any of the components were restarted, and we'll show this on the graph. And components could restart when user changed some flag, or maybe there was an out of memory exception, etc. So still it helps you to correlate the events of the changes. We also track a number of logs generated by VictoriaMetrics components. So when component gets overloaded with, for example, bad requests, you will see the spike in logs, and you can go and read those logs. But if you don't see, if you don't have access to those logs, you can still have the line of code which generated the error line. And you can go to the source code on the GitHub and check to which error this log is related to. Alerting rules. So as with dashboards, all the critical VictoriaMetrics components are shipped with recommended alerting rules. Those rules are supposed to track critical metrics and notify user with a good message, and this message should contain a context and a basic understanding of what is happening. So here's how alerting rule looks like. For user, it's not important the title, the expression, and other settings. What is important is the summary and description. And this summary and description should contain enough information for user to understand what is happening, what are the consequences, and what he can do with this. So this is the basic understanding of what's happening, and the context is the dashboard link. So this link will take user to the same dashboard that I showed you a few minutes ago. And if user will click on it, he will be taken to exact moment of time when this annotation was generated, and the panel which shows the anomaly. And this gives even more context, so you can see how retrospectively this metric changed when the alert became firing. So you can see what happened to your system and use that for troubleshooting. We also do this via annotations on the dashboards. Okay, documentation. So we pay a lot of attention to documentation, and in our project it contains like 51,000 of lines. It is not like we every day add a new guide, a new example, not like this, but we usually, we frequently update the documentation. We try to keep it fresh and consistent. And how we do this? Well, we accept only those PRs which have these 4 things. First, the actual change, the code change, maybe the feature or bug fix. The second is the test, which will verify this change works. The third is the update of documentation. So if you introduce new feature, well, you need to explain this feature in the documentation or update the other feature that you changed. And also, you need to change it in the changelog. So when we make a new release, users will get the really good explanation of what changed since the last release. Okay. So we reuse this documentation across all of our resources. And we use links to our docs in error messages and logs generated by VictoriaMetrics components. We also put them into alerting rules. Dashboard has links to documentation. We also refer documentation on GitHub issues and on community platforms. We do this because search engines usually scan GitHub, and they scan Reddit and Stack Overflow. So when user will type some question into Google, like how to solve this bug in VictoriaMetrics, he will be taken to a specific GitHub issue, which elaborately explains what is going on and how to fix this. And we also want to keep this backward compatibility with documentation links. So if there was a Stack Overflow question answered 3 years ago and it contains a link to the docs, we need to make sure that this link still works. We do not break links, so users that will find answer on the Google will be taken to the Stack Overflow. If he clicks on the link, it should work. Yeah, and we do really care about our docs and our dashboards because we use them every day. And how we use them exactly? Well, we have a service called monitoring of monitoring. So there are users who are willing to sign a support contract so we can help them with their installations. And to help them, we provide a service where they can send the metrics of their installations to our central database where we collect them. And it is in this central database, our engineers use the same dashboards, the same alerts, and the same documentation to look after those installations. And this helps us to keep it fresh and gives us really good visibility of what is happening. Just for example, this Monday I had a call with one of the clients, and a client was implying that VictoriaMetrics behaved weirdly. It stopped accepting writes. But thankfully to the dashboards, I was able to prove that VictoriaMetrics wasn't the fault here, that instance, something happens on the instance and another process consumed all the CPU. So it broke the physical machine completely. Without the dashboard, without the troubleshooting tool, I won't be able to prove it, and I will spend a lot of hours trying to understand what is happening and why this client is not happy. So this is how our monitoring of monitoring works. Usually the system is good, but out of sudden we could receive an alert. When alert is received, someone from VictoriaMetrics engineers take a look, reads the explanation, goes to the dashboard to identify the real issue, checks the documentation, maybe checks the code, identifies what could be changed, and recommends or applies some changes, and then we get back to the good state. So this is what we do every day, and this is why we care about troubleshooting and our docs. That's mostly it of my talk. You can find the this slide is available via QR code, so you can click on these links. The first link will take you to the live playground of VictoriaMetrics, where you can see this dashboard that I showed. You can click on it, you can see the queries, you can see how this everything is connected. That playground is under the constant benchmark, so it has the real production data or something like that. So it's pretty representative. You can also find all these dashboards, alerting rules, and documentations that I talked. They are all open source, available in our repo, so you can try reading them. Maybe you will find something interesting. And that's all. If you have any questions, I will be glad to answer.
All right, everybody, here are the good questions.
Simple question. You showed us that you accept PRs only if they change the changelog files or documentation. Do you have an automation managing this, or you manually check for that?
We manually check for that, and unfortunately, accepting those PRs is pretty hard, and pretty hard from the managing the community, because you can't ask a person to do all these things correctly, because this can discourage people to contribute to your project. So what we usually do, we require this from our engineers, who are maintainers of the project. But if someone third party will send us a PR, we usually do follow-ups. So we accept the PR, and the engineer who accepted and merged that PR will do a follow-up commit, which will add this missing stuff if needed.
Thanks for the talk. So in what way are the publicly available dashboards that are maybe that you listed just here and the monitoring dashboards different? Do you sync changes in some way? And how do you manage that? Do you just copy JSON widgets around? And how do you make sure like the PromQL or your other expressions aren't broken, that your alerting rules make sense? Sorry, it's 4 questions in one, but yeah, I guess, how do you manage the life cycle around these dashboards and the alerting rules?
Sure, so we are a monitoring company, so we do monitor all this. And for dashboards, we have GitOps approach, which periodically syncs changes from the main repo and get it uploaded to the monitoring service, which is private and not visible to users. But it does periodically sync the dashboards from the upstream. And for the broken rules aren't detected when they push to the master. But when we have evaluation of these rules, this is also monitored. And if something is failing to evaluate, if PromQL expression fails, we will get another alerting trigger.
Any other questions? No? I have one. So, you know that meme where it is like the junior developer says, hey, what is the documentation? And you have the senior developer that says, I am the documentation. That happens a lot. How come do you focus so much on documentation? Is it something that VictoriaMetrics has in its foundations or personal experience?
It's a foundation mostly. Our CTO is pretty, not maybe restrictive, but he has this experience that projects without documentation do not live long. And he spends most of his time on making this documentation really good. And this is part of our engineering culture. We all look after the documentation if we find a typo, if something is just formulated incorrectly or not good, or if user complains that, hey, I read this part of documentation and I still don't understand. Well, it's just a matter of minutes to rephrase it, to make it more clear and make a pull request. That's super easy.
That's awesome. That's super awesome. Anybody else? No questions? Perfect. So let's give it up once again for Roman. This is your trophy for you. Thank you very much.